welcome to another episode of Science in Sarah's Kitchen. Today I have a lovely guest host. This is Dr. C, aka Choya. She's going to clean the floor for us to make sure that there are no bad things that we step on. Today's experiment, we're actually going to be doing two different experiments. We're starting off with supercooling some water. So the basic setup that we have is a cooler. I have some ice and some water in there, and I have two different things of water. This was a water bottle that I emptied, dried out, and then I put some distilled water inside this first container, of course, making sure to leave a little bit of space at the top because, as we know, water is that one unique liquid where when it gets colder, the unique substance on the planet Earth, when it gets colder, it expands, so we need a little space for that. And second thing we have in here is, just to test it out, some Market Pantry purified drinking water processed by advanced filtration and reverse osmosis technologies. High quality stuff. And of course, we have a thermometer in here to assist us in taking our temperatures. It's a real scientific thermometer, so it is just in Celsius. Kind of cool. And so at this point in time, it has been sitting in here with my water and ice, and it, drops down to about 0, which is not enough for us to get that super cooled situation. So in order to super cool it, we have a special guest who has brought a special supply for us to use. So everyone, round of applause for Dr. B. Come on in. Come on in, Dr. B. Way to go. Way to go. AKA the husband. So, Dr. B, do you want to explain what you've brought and why it is going to help with our experiment today?
Well, first I brought calcium chloride, but even though it's fancier than the other ingredient in name, it's not actually going to do as good of a job as just basic sodium chloride, which is, of course, the main component in common table salt. However, this is more pure, and what it will do is reduce the freezing point of the ice, thereby allowing it to get much colder.
He's really excited, as you can see.
I know.
He has a degree in organic chemistry. Dr. B. Thank you, Dr. B. What's your recommendation on amounts for us to use with sodium chloride?
Well, you'll probably have to cut back on the amount of ice you have because it's supposed to be 1 to 3.
1 to 3.
And you shouldn't probably use all of that.
I probably shouldn't use all of this since it's like halfway full. Okay. So Dr. B has given me a little bit more advice in our experimentation, and so if you have the capability to do this, if you have a nice fridge that will crush ice for you, crushed ice is actually going to work a little bit better than having whole chunks of ice. And we now have our mixture, so Dr. B is going to help me add our sodium chloride. Of course, always important to not use your glass thermometer as a stirring mechanism. We've got a handy dandy Betty Crocker spoon for that. Add some in, kind of a 1 to 3 ratio, but that's by mass, which is a little bit hard to do. We have our thermometer though that's going to help us with telling what the temp is, and once we get this cooling, we're actually going to move on and do the preps for the next experiment, and then we will come back and see how our ice is doing.
Hello everyone, I have now moved to the floor of the kitchen. We are on to the next step and Choy's come to help. Careful, honey. Our next step is to prepare some dry ice, which I have triple bagged just to be safe. We're of course not going to touch it with little paws or our hands because it is extremely cold. But because I was only able to purchase it in a large block, which is the way you can primarily get it if you are purchasing it at a grocery store, that's what we gotta do. So we have a hammer. Choya, you better back up. And we're going to now break the dry ice, which is actually very easy to do. Dry ice is actually, hi honey. Dry ice is easier to break than if you had like a regular big old block of ice. So use the hammer. Up to a nice fine powder. It helps, we have a tile surface here. I'm not going to break the tiles on the floor though. Okay, so we got our broken dry ice. We can get back off the kitchen floor and move on to the next step.
Hi everyone, Choya and I are back for some more fun. We of course live in the Tucson desert, so making our own snowflake is not something that we would normally be able to do here in the desert, though we do actually have snow out in the mountains not too far away. But what we are going to do today is use some dry ice to make our own snowflakes. Aren't you excited? Yeah, she's even wearing her hoodie to stay warm during our snowy excitement. So you go off and have fun, and I'm gonna get to work. So I gathered some supplies. I'm from the Midwest, so it's a pop bottle. And I'm gonna cut off about 1/2 inch from the very top of that pop bottle. Need it to be thick enough that when I take my handy dandy scrub sponge and put it inside, that it's about that thickness, because I'm gonna be attaching what I cut out inside our container. And I have some safety pins, pulled out the sewing kit, because those are needed as a supply, and a thimble, because we're gonna be pushing things through. So, step 1, we're going to very carefully cut, again, about 1/2 inch. This sponge is actually 0.6 inches, so I'm gonna go just slightly above, and we're gonna carefully cut away from ourselves. Whoop. Maybe we'll cut away and come back to a perfectly cut container. Let's come back to a perfectly cut container right after these breaks. Welcome back, everyone. While you were away, I used my handy dandy knife to bisect my lovely former pop bottle. And I am now in the point of cutting down my sponge so that it's going to fit in the top of the bottle. I found for this, it's just easier to use my scissors and cut it into the circular shape that I need so that I can attach it. Continuing along. There we go. Okay, give it a test. Beautiful. So it's fitting in there. And here's where my handy thimble is going to come into play, because I have some holes that I need to make. So one of those holes is going to be coming in from the very top, pushing that hole through. Careful not to stab myself. Oops, I got 2 needles. Come apart. Okay, so 1. And then I will go through with my other 3 so that I get it so that my sponge is going to be suspended. Welcome back, everyone. So we're taking a break from the bottle. I'll explain why it's being annoying in just a little bit, but we're going to go back to our super cooled water, and the reason why is that it is only going to stay super cooled for a certain amount of time. So I have my guest Bob, who is yet another STEM professional, so you know he's into this kind of stuff. And we have our thermometer, and we're looking at about 5 below Celsius. Bob, you seen that?
Yes.
Seen that? Okay. So that's about the ideal temperature for our experiment. And as I said, we had 2 different types of water, and we had our purified water and our distilled water. So Bob, would you like to do the honors? As he takes that out, he's going to take it out really, really carefully so as not to disturb it. And then we're going to do a sudden disturbance where we are going to slam it and hope that it is super cooled enough that basically it's actually not as instantaneous freeze. We're going to see freezing going through the bottle from the top to the bottom. So the moment is here. We shall see. This is experiment number 1 with the purified drinking water from Target. Ready, set, oh wait, this thing's on here. Okay, slam it. Oh, it worked! Okay, now get this. We actually have the ice freezing its way all the way through. Hard to see, of course, on a camera like this, but we just froze it all the way through, and I'm very happy that there was a little bit. There's Dr. B. He's excited by this too. Yeah, we froze it. Yes! Woo! Science! Okay, try number 2. Oh! Looks like maybe we've got a little bit of cooling going on. A little bit of ice may have formed on the outside of this. This is interesting. This was a bottle that had just regular water in it. I drank all of that, and then I replaced it with the distilled water. So there may have been just enough of the nuclei for some condensation or for some ice formation on the exterior, but the interior still looks wet to me. And at the top, we can see it moving. So here we go. Last one. 3, 2, 1. Let's see. I don't see any changes really.
No.
No? Dr. B, anything? Anything? No. Okay. So we have learned from our experiment that perhaps if this had been more thoroughly cleansed prior to this, or if I had bought something, I haven't found purified water in a water bottle, and I didn't want to go shopping for that. But we were successful We do have our purified drinking water, once again processed by advanced filtration and reverse osmosis technology. Go buy it at your local Target and have some fun. Thanks, everybody. We'll be back in just a bit to talk about why bottles are awful. Okay, welcome back, everyone. So we've moved on to the next step. We have our pins that are sticking in. We have 4 pins holding this in place. We had made our hole. I ended up using a hammer and a nail to make the hole in the bottom because I found that the bottom is very strong in this container. I put this nylon thread. You can use fishing line or you can use some other sort of thread that you might have in a sewing kit. I put it through that hole that was created, and once it was all the way through, hung it long enough that I can now tape it on the top. And then the next step was to tie on, I put a bright red paper clip so that it's a little bit easier to see. With that paper clip, the important thing is that it needs to be dangling so that it is not actually touching the bottom of the container. It needs to be freely dangling. So that's the length that I have it set at. And our next step is going to be putting it inside a container. I did not have a styrofoam container that's the right size. This doesn't work because we need to have about 1 inch of our plastic bottle sticking out, and we can't do that with that. So I have a Wisconsin Badgers cup that we will be putting the dry ice in, and we're gonna have to compensate for the fact that this is not as good in terms of insulating properties. So we're gonna have to put some stuff on to insulate it to get it cold enough, and then we're gonna be filling in the dry ice around our container. So moving on to that next step with the dry ice. Okay, folks, we are back. So our next step is to really get this kick starting. We need to use, I just put some regular tap water, and I'm wetting the sponge down, getting it with a nice amount of tap water in it. And then the next step is going to be to put it back on its place happily, and then we have our container. And so we are going to be filling the sides of the container, completely surrounding our plastic bottle with our dry ice. Again, be careful with the dry ice. If you don't have an easy way to adjust it without touching it, make sure that you're doing this with some gloves. So I'm being very careful as I pour from my plastic bag. Ooh. And I'm gonna move it back so you can see what's going on. I also have an audience. Miss Choya is very excited to see this dry ice form into snow. We're going to fill it in all the way around our plastic bottle. All of the sides need to have dry ice. And then once we get that done, we're actually going to put some sort of, I think I'll probably just put some paper towels or some tape over this so that we have a nice good seal here, and then we're going to put lots and lots of insulation so that it's keeping the cold in. And we're going to see if we can get the vapor deposition that we need to happen onto our dangling, and it still is dangling in there, piece of nylon thread. So we'll keep going with that dry ice. Much like a Choya puppy is most happy when thoroughly insulated in her soft, fuzzy blanket, we have also thoroughly insulated our ice making toy, and we're going to let that sit for a little bit of time. Like I mentioned, I have some paper towels along the top of it, as well as having it wrapped up in a blanket because I don't have a really thoroughly insulating container. And we've got extra dry ice. So if you got a little extra dry ice and you want to have some fun, highly recommend getting some warm water, throwing it in. You can carbonate it yourself. You can also do activities where you make your own root beer soda or root beer pop, whichever way you want. Soda sounds actually right for that one. Or you can do your own witch's brew and make boo bubbles. There's a lot of fun things that you can do. So if you're doing this experiment, look up fun things that you can do with dry ice as well. Choya's gonna go to bed now. She's tired. Welcome back, everyone. Here's some of the goo soap fun we're having. Also, we have a paper cup. Whenever you're taking out your dry ice, paper cup is better than, say, using something metal. If you put something metal in there, you'll get the experience of the sound of the screaming metal, which is kind of painful. So I have my cup of water here, and there's some soap already in it, but I'm going to put some more dry ice to get it going again. And then I have a container that has a mixture of water and soap, and a paper towel that I just kind of folded up. And so you can get it sometimes to make a perfect seal and make it as if you're gonna blow just a straight bubble, and then that single bubble will actually blow up. You'll kind of be able to tell somebody's fortune with it. Right now it's just bubbling everywhere, but oh, we got soap. We can clean up our own mess. And science is fun until it gets messy. Then it's awesome. This we're going to be taking out in just a little bit. After about 5 to 10 minutes is when we should have our first ice crystals. Should we check it out? I think we should check it out. Let's see if we have anything going on. We're going to leave the main part of the bottle in there. And we're going to lift this up. And I can see a few little crystals forming. Not anything really big. But I did bring enough handy dandy magnifying glasses for all of my assistants, not including Choya, to be looking at. But I think we're going to let this do its thing for a little while longer. Make sure as this is going along, obviously you're going to have sublimation occurring. This is dry ice, carbon dioxide, nothing to worry about, but it is going to be slowly dropping in level, and so you're going to need to replenish your dry ice as you go along. After about an hour is when you're going to get to your optimum level of having really nice snow crystals that have formed. And thing to know about the snow crystals is that they need something to form on. They're not just going to form on their own. I like to say they need a party planner. The party planner is like, hey, you come over here and you come over here. Let's all get together and have a party. And that's when the crystals are going to form, is when you have something that sparks that. Oftentimes in the atmosphere, that's going to be a piece of salt, some dust, even small floating singular cellular organisms can be in the center of every single snowflake that you have, and every single little water droplet that forms as well. Okay, so welcome back everyone to this final bit of Science in Sarah's Kitchen. My co-contributors have pretty much gone to bed, and so it is up to me to finish off the experiment for the end of the night. So in conclusion, for our with our super cooled water, again, we dropped this below 0, but because it didn't have anything inside of it for it to form ice crystals around, it will drop below 0, and then when we slammed it, it adds a little bit of energy into the system, which is enough for the crystals to form, because the crystals actually do take a little bit of energy. So our purified drinking water ended up being our best for that, and as you remember, when Bob slammed that down, it turned into a beautiful, beautiful frozen container. It is now thoroughly melted, and we may have to do that experiment again, because that was actually really awesome. Continuing on with what we're doing with making the snow, haven't checked, so we're going to all do this together. Pulling this out, I have added more dry ice as we went along. Again, we've got dry ice completely surrounding our bottle, which is inside that Madison cup. I'm going to pull this out carefully. And right at the very top, I know my camera is going to do maybe a bad job of showing you, but right at that very top there, I've got some crystals growing, and now they have literally melted in the amount of time that it took them to be outside of the container. We also have crystal growth that has occurred all around our paper clip. And so maybe we'll leave it overnight and see what happens with that. Of course, I will not be adding dry ice overnight, so it probably won't work. But if we were to let that go a little bit longer, I do think we would have seen a little bit more growth of those ice crystals, and a little bit more of our own little fake snow for us here in the desert, where today's high was in the 80s. So a little taste of a winter and good riddance to it. We'll go back to enjoying our summer. Hopefully you had a good time with this latest episode of Science in Sarah's Kitchen. Stay tuned. There will be, of course, many, many more opportunities to have fun in your kitchen as well as in mine in the future. Thanks, everyone. Thanks to my guests, Dr. B, and Bob, who is actually an engineer by training, and of course Dr. C, Choya the puppy, my wonderful, lovely co-host who needs to go to bed now. Thanks, everyone.